any kind of numbers, those numbers can be positive numbers, and the other kind of numbers can be any kind of negative numbers, right? So in another classification, this again further divided, like we can able to take a positive number can be a fraction once again, right? So if I am going to take 5.76, it is a fractional number. 5 is an integer and 0.76 is a fractional number, right? And I can call this number as floating point number also, right? Because here the point I am going to move from towards right side or towards left side. If I am going to place this point towards completely right side, this is normal integer value, right? If I am going to put this point value towards completely left side, I can call it as a fractional value. If I am going to combine these two, I can call it a floating point number. For this, I can able to append negative numbers also, right? It can be classified in many ways depending upon the number we are trying to represent. Okay, basically if you observe, it can be a positive number or it can be a negative number, right? Positive number, how we are going to write? If we are going to take the number like 5, are we going to place any sign here? No. As we are not going to place any sign, I can technically call it as unsigned number. One kind of classification is unsigned number. Another kind of classification is signed numbers, because we are going to place here compulsory sign representation, right? If I am going to represent the negative 5, I am going to prefix with sign. If you want, you can able to represent plus 5 also. There is no problem. This one I can call it as signed representation. Okay. Basically, we are not going to place any positive sign symbol prefix with any number if it is a kind of unsigned number. Okay. In the system, how this negative number is going to be stored? That is the question, right? So while studying any kind of C language or any kind of Java language, you have studied some point like all the numbers in the C language or in Java language is going to store in the form of complementary system, right? All positive numbers are going to store directly, whereas coming to complement numbers like negative numbers, they are going to store in the form of complement of the actual system, complements of the actual system, right? So let me come to this point later, what do you mean by complement of a number system. Okay, fine. So before that, if you would like to represent the number 5, number minus 5 in the system, one of the representation is how we are going to represent the number 5. Can I call the number 5 as 101? Yes or no? 101. I am going to take one more bit, which is meant for sign representation. Where I am going to consider 0 as positive value, 1 as negative value. Now try to observe what is the value of this one? 5. Prefix most, this one I can call it as most significant bit term. This one I can call it as least significant bit. Okay. If most significant bit is 0, I can mark it as plus. If most significant bit is 1, I can mark it as minus. And I am going to calculate the remaining value 5. This is what I can call it as negative number representation. Right? But the thing here is, if you would like to represent any kind of a negative number, there is no problem. It is easy for us to represent. But what about the system representation? Right? For example, I am trying to give two numbers 5 and 6. And as I am trying to give 5 and 6, system will convert it into 101 and it will be converted into 110. It is going to calculate 111011, that is 11. This is okay for you. Okay, fine. Basically, if it is binary system, they are going to prefix with 0b 101, 0b 110, so the system will understood that it is a kind of binary number system. So that it is going to get the result as 11 base 10 in decimal format, decimal number system. Okay, if now I am trying to give a number 0b 0101, 0b 1101, in my point this is minus 5 and in my point this is plus 5. What about system? How can we explain to the system that this is plus 5 and this is minus 5. We have to design the system in such a way that it has to identify always the most significant bit. If most significant bit is 0, I can consider as a positive value, otherwise I can consider as a negative value. Like this, I need to write the program for each and every kind of number in programming, right? But the thing is, this is a difficult task. And one more thing is, when you are going to represent any kind of representation in the form of like this, like minus 5 or plus 5, whatever the number representation, you are trying to perform some kind of operations, something like addition operation. If you are thinking that I am trying to perform addition operation, 5 over 5, what the system will do? System will generate the number 10 perfectly. There is no problem. If for the same system design, for example, this design is look like this. See, don't think about this is the exact structure. If you are going to give 5 and 5, it is going to give the result as 10. We have designed this circuit in such a way that it is going to work for the inputs of two numbers, both are of type positive numbers. There is no problem. But if I am going to give the number like 5 and minus 5, what the system will do? This circuit is meant for the performance of addition of two numbers, not for the performance of addition of one positive number and one negative number, right? So at the time, what you have to do? You have to design one more circuit like this. See, this is not the exact one. I am just saying that you need to compulsory modify the circuit. Then only it can able to allow for performance of addition of one positive number and one negative number. So to overcome this drawback, what the earlier authors did is, why can't we take a single circuit? So that the same circuit will be used for both addition as well as subtraction, so that logic will be reduced, so that circuit design will be reduced. If circuit design will be reduced, our chip design will also be reduced. Am I right? Yes. I mean, if you observe here, instead of giving the 5 minus 5 as input to the system, can I write like 5 plus minus 5? Can I write 5 plus minus 5? So that now the same input will be given to the same circuit. If I am going to get 5 plus 5, I can also give it to the same circuit. If I am going to have minus 5 plus 5, I can also give it to the same circuit. If you are going to get like minus 5 plus of minus 5, the same circuit will work for any kind of input, so that the same circuit will yield the same result. Okay, so this is the reason what the authors will come up with a new solution. That new solution we can call it as complementary of a system. Complement of a system. Okay. So here you have to understand one technical point. So sine numbers we are going to represent in the form of one way of representation that we have seen right now. This one I can call it as sine magnitude representation. Sine magnitude representation, where one bit will be completely allocated for sine bit, one is meant for negative, 0 is meant for positive. And in another way, I can represent the sine numbers is, one is b minus 1's complement format, and another one is b's complement format. Right? So we have seen the drawback of existing system like signed magnitude representation, where we need compulsory different kind of circuits in order to perform various kind of operations. Instead of that, if you are going to learn the complementary of a number system, you can able to get only one circuit in order to perform various kind of operations.